First of all, the apparatus that we're going to use for the direct shear test. So this is the direct shear machine. This is the direct shear box which is placed inside the machine right now, and this is the loading wheel from where the load will be applied, and this is the hanger to apply the normal load over the sample. Only the weight of the hanger itself is 8 pounds, but the normal load will be applied added manually, and there is a proving ring to measure the applied horizontal load or the shearing load. The horizontal load will be applied from left to right and will be recorded, will be read from the proving ring dial gauge, and the horizontal deformations, the shear deformations will be read from the horizontal dial gauge, which will be in contact with the shear box. So these are the other various components which will be placed inside the shear box, and total 3 sets are here right now in order to perform 3 direct shear tests. So first of all, this is the top part of the box, and this is the bottom part with holes at the diagonal place to fix it with the top part. Now this is the bottom plate with projections on top, and it will be placed inside the shear box such that the projections are perpendicular to the direction of shear. So this plate will be placed at the bottom, and then these are the porous stones usually placed over the bottom plate. So the bottom plate first, then the porous stone will be placed over it, and then shear plate will be placed over it. So these are the shear plates with perforation over it in order to apply the water to get to the soil. And you see there are two kinds of shear plates. One is with perforations and the other one is without perforations. So this is used for undrained shear test, and the other one is used for drained shear test. So we're going to perform the drained shear test right now, and the other one we're going to keep it separate. So you place the bottom plate, then the porous stone, and the bottom shear plate will be placed such that its projections are facing the soil. Soil will be placed over it and its direction perpendicular to the direction of the shear. Now the soil will be placed over it, and over that another shear plate will be placed. Similarly, that will be in contact with the soil, and the direction of the lines perpendicular to the direction of shear. And now over that porous stone was placed, and now the top plate is placed. This whole arrangement will be made inside the shear box. Sample preparation. This is the sand sample that we are going to use for the test. So we calculated the weight of the sample from its density and volume of the shear box, and we are going to weight and prepare 2 samples for 3 direct shear tests. So these 3 samples are prepared. Now we are going to prepare the sample inside the shear box. First of all, place the bottom box inside the box, the bottom, and it's sliding inside this box like this. This is going to be fixed at its place. Now the bottom plate with projections perpendicular to the direction of the shear, and the porous stone the shear plate with its projections perpendicular to the direction of the applied shear. And now the sample will be poured inside. First place the top part of the box and see how it's moving. It's going to move like this. The load is going to be applied and it's going to move forward. For now, it's going to be fixed to the bottom section with the help of two locking screws. Now the sample will be placed inside. This is the sample that we made earlier. Level the surface of the sample or compact it inside the box by using the top plate. Now place the upper shear plate that we're going to place over it. Once it's compacted enough, place the upper shear plate over it with projections which are perpendicular to the direction of the shear and in contact with the soil. Now the porous stone will be placed over it and the top plate will be placed over it. The sample is ready and now it's going to be placed inside the shear machine. The shear box is now placed inside the direct shear machine. Water is added. Now the shear box is set at place such that it's in contact with the horizontal gauge and the proving ring as well. Lock it, and now we are going to make the proving ring to touch the shear box. By moving this manually, we are going to move the shear box and get it in contact with the proving ring. Unlock the screws and loosen the screws a bit to create a space between the upper and the bottom box around equal to the grain size of the soil that we're going to test. Now the loading hanger is placed over it and the normal load will be added. Starting the test, we are going to prepare this table. Sample 1, normal load 10 pounds and a horizontal deflection interval of 20. We are going to measure or note the proving dial gauge readings. Before starting the test, make sure that the dial gauges are set to 0 and you have prepared this table. So you see the dial gauges are set to 0 and now we're going to start the test. The load is started to fly and the gauges are started to move. So at intervals of 20 divisions of horizontal dial gauge, we are going to note reading from proving dial gauge. We are going to keep applying the load until the load holds constant for consecutive 4 intervals. At the end of test, we are going to remove the shear box first. Remove the normal load and then remove the hanger from here. Place the steel ball back to its place, and then we can take out the shear box and place the new shear box inside. So this is the test number 2 for 20 pounds normal load. Second sample was prepared of the same soil and 20 pounds normal load is applied, making the dial gauges 0. And now we are going to start the test. So this is the sample number 2 at 20 pounds of normal load and at horizontal deflections of 0, 20, 40, 60, 80 and up to whatever the value. And now this test has been started. We're going to note the values from the proving ring the same manner that we did for test number 1. So the test number 3 at 30 pounds normal load, the sample was set and 30 pounds normal load is applied. After setting the dial gauges to 0, we are going to start the test. So you have observed that at 10 pounds of normal load, the value of shear load was less, and at 20 pounds normal load the value of shear load increased, and at 30 pounds the value of shear stress is going to be more than as compared to 10 or 20 pounds. One more thing, as the load was applied, the area keeps on changing while the sample was shear. So while the shear stress was applied, the sample's area was constantly changing, so we have to apply the area correction like we applied for unconfined test, and now we are going to get it applied here as well. That is shown in the calculation table how you can apply that correction. And similarly, this test will be continued until the load value holds constant for consecutive 4 intervals. As the load is applied, it applies on the shear box, and the horizontal or the shear displacements are made from the horizontal dial gauge, and the load is being measured from the proving ring. So now switch off the machine, and the test is completed. Do calculations and make graphs and report the results. That's it. Thank you very much.